All right, we're going to go into our last chapter for the semester. This is chapter 7. And in chapter 7, we're going to talk about rational expressions. Now, here's the thing. Whenever you see the word rational, you need to be able to see the word that's contained within it. And that's the word ratio. So with ratios, we talk about comparing, two numbers. Okay. And with a ratio, we can express those guys as a fraction. So things that are rational are things that can be expressed as a fraction. Okay. So the way we define rational expressions is like this. A rational expression is the quotient of two polynomials. It's the quotient of two polynomials, p divided by q, where q does not equal the zero polynomial. We know that we run into issues when the denominator of a fraction is equal to 0. Because when the denominator is 0, what do we know about the expression? It's undefined. It's undefined. Okay. So let me just give you some examples of what rational expressions look like. Just any fraction, really. So if I say 7 over 15, that's a rational expression. It's just a fraction. Okay. If I have x plus 15 over x minus 8, that's just another example of a rational expression. It's something a little bit more complicated. But what you see is that it is a fraction, and that your numerator and denominator are both polynomials. And we can make things even more complicated than that. Say x to the 173rd minus 2x plus 10 over 2x squared minus 7x plus 6. These are all examples of rational expressions. Okay. Now what we're going to do with these guys is the same thing that you've done with fractions from before. We're going to talk about how we can add, subtract, multiply, and divide these guys. And in the next class, in the next course, you will talk about how these guys come into play with word problems, solving equations that contain these guys. Having fractions within a fraction. But right now, today, we're just going to look at the basic operations. Now, before we do that, we also like to talk about something called restricted values. Now, this is a concept that connects to something you're going to see in the next course called the domain. Okay. Now, with restricted values, these are just the values that are acceptable to be, to plug into these expressions that we have. So, a restricted value is something that you can't plug in for one reason or another, and basically our reason is that we don't want to have the denominator equal 0. We've already talked about how that would cause the expression to be undefined, and we don't want that. So, a restricted value is any replacement of the variable that makes the denominator equal 0. Any replacement of the variable that makes the denominator equal 0. This is a restricted value. And now we've dealt with things that are very similar to restricted values before. You go to a dinner party and you know that maybe there's something with the host that you shouldn't talk about. It's like, oh, I forgot. I need to tell you, whatever you do, don't bring up his kitty, Sancho. Okay.
Sancho? You know what that is in Spanish?
No.
It's like your how do you say it?
Like the other woman or the other man.
Like the other, like if your wife has another guy, you know?
Mistress.
Oh, so Sancho over Sancha.
Yeah.
Okay, well. This is why you don't want to bring up his cat named Sancho. Okay? And so you know, oh, I shouldn't talk about that, so you don't talk about it, right? You find out what would make the conversation go the wrong direction, you just don't mention it, right? Like if, you know, somebody is a, you know, never mind, I just... What? No, no. It's like, you know, you may have one political leaning, but you know this person goes the other way, and you know if you guys start talking about it, it's going to be horrible. So you just avoid that, right? You just agree to disagree and still think the other person's wrong. So if I take this expression right here, x plus 15 over x minus 8, I could plug in pretty much any value of x that I want to. And when we're talking about the domain, that's what you're talking about. The domain is the set of all x values that can be plugged into an expression. But is there something that I can't plug into this, guys? Is there something that would cause me to have problems? 0? If I plug in 0, then I basically have this guy, which would give me negative 15/8.
You're trying to get deeper.
I'm trying to make sure that I don't end up with a 0. Where? In the denominator. So you have to be thinking this. Okay? I need to be thinking, okay, when does x minus 8, when does that denominator equal 0? Does that denominator ever equal 0? Could it?
Yes.
When?
When you have 8 minus 8.
Right, so when x is equal to 8, right? When does x minus 8 equal 0? Well, like you said, if x is equal to 8. Are you with me?
Mm-hmm.
So what that means for me is that this guy right here, this is what we call our restricted value. He is what makes that denominator equal to 0. Okay. So when we talk about the domain, you may see something like this. So the domain will be the set of all x's, and we'll use a set builder notation like that. Use a vertical bar to mean the word such that, and this is where you kind of give the condition. The domain, meaning all the x's that I can plug in, is equal to the set of all x's, provided that x does not equal 8. So what I'm saying is I can plug in any value of x that I want to, except for 8, right? Because if I plug in 8, what do I get in the numerator?
0.
In the numerator? 8 plus 15 is what?
22. 23, 22.
It's 23.
Right the second.
You
Money, man.
all right, so 8 minus 8, if I plug in 8 in the denominator, what do I get? What's 23 divided by 0?
At all? Can't do it.
It's undefined. Don't say 0 or you can't do it. It's undefined. What? What? Do I need to have a... Is my crazy face not enough for you? When the 0 is under the line, the expression is undefined. Forget that. I don't know why I'm here today. Maybe I shouldn't record. I'm not going to record. I'm just going to turn this thing off. Let's look at the other expression. Maybe you guys can redeem yourselves. Maybe? Yeah, I think so. It's like the stoner talk right there. Yeah, man. If I could... Yeah, 0, man. It's like no solution, yeah. So when I like look at this problem and stuff, man, it's like, you know that.
Oh my God.
Oh, dude. So it's like I don't even care about like the numerator, you know, because like the numerator could be 0 and I don't care. It doesn't matter. But like if the denominator, oh, dude, if the denominator is like 0, whoa. So let's set the denominator equal to 0. Let's solve this. Do you know how to solve this? You like to do like 2 parentheses or something, right? Yeah, that's groovy, man. Right, because I could try no, you.
You do. I'm just saying.
How does it factor?
What?
Huh? What? Because see, you're trying to solve this equation equal to, I don't care about the numerator. I want to know what makes that denominator equal to 0. And I'm going to avoid those values. They're going to be restricted values. So, I'm just going to give you a hint. 2x squared breaks down as 2x and x. I knew you guys were going to do that anyway. And I bet you already know your signs. They're both going to be what?
Negative.
Positive, negative? How about negatives? 2 negatives, right?
2 negatives.
Yeah, uh-huh. How do you break down the 6?
1 and 6, 2x.
1 and 6, 2 and 3. There's so many different ways. What's it going to be? Well, let's see. 1 and 6?
Yes.
If I do 1 and 6 like this, I get 1 and 12. Wrong. Try again.
3 and 2.
Maybe I should put the 6 with the 2?
You
No.
can't do that. 6 and 1.
Why can I not put the 6 with the 2?
3 and 2.
Because
Common factor. I didn't have a common factor. You can't have it here. That means I've got to use the 2 and the 3 for the 6. Can the 2 go here?
No.
3 goes here. 2 goes here. Does it work out now?
Yes.
I get a negative 3x and a minus 4x. When combined gives me a negative 7x. So I solve each of these. That means x must be
3 over 2.
positive 3 over 2. Or what?
2.
These are my restricted values. These are the bad guys, all right? These.
Positive 3 over 2.
Why what?
When it's negative 3 and
Here?
If you add it,
If you set this guy equal to 0, you have to add the 3 and divide by 2. And that's how we get the 3 halves. If you need to take it off to the side and work it out, you can. I am not going to do that. Step by step, you'll get positive 3 halves. So when I talk about my domain for this guy, my domain is equal to the set of all x, but we have some restrictions on x. I can't just plug any value of x in. What are my restrictions?
3 over 2 and 2.
Well, x can't equal 3 over 2, and x also cannot equal positive 2. Right?
Yes.
Those are your restricted values. So I can plug in anything into this expression as long as I don't plug in 3 halves or 2. Because when I do that, my denominator equals 0. And when your denominator is 0, then what?
It's undefined.
It's undefined.